I smell like Geiken fluid.
Oh, it's a special kind of smell. We're back today to talk about the OSGiken for our Bmod car, Ryeth.
Here it is. And we have gone through all the CAD work to get into a point where we can see if it'll fit and everything. Good news, it does. So we figured we'd give a little bit of background on how we got to the point where we're at now and then share some of the design process.
Main reason that we went with the Geiken is we've had a lot of success with it in our D-Street prepared RX-8, and the diff works around your setup as opposed to having your setup work around your diff. If the rear wheels are equally locked left and right, it's going to be trying to make the car drive straight versus an open diff that allows the left and the right wheel to rotate independently is going to allow the front end to really work and turn. So the downside, of course, of an open diff is when you're trying to get on throttle, if you light into that inside wheel at all, you're going to get into that one wheel peel sort of situation, which you don't want. We also experienced that in our outing with the Bmod car this fall, and the car was just lifting up an inside wheel, started getting spin up, it'd land, it would upset the car, we'd get snap oversteer. So that's where the Geiken comes in, where as you apply torque, the rear wheels are going to lock and not allow that one wheel peel to happen. But as you come off of the throttle, as you're turning in for a long, slow corner, it can actually act like an open diff and let the front end really work. A two-way is equally locked on throttle as it is off throttle relative to the torque input. A 1.5 way is going to be half as locked off throttle, and a one way is going to be as open as it possibly can be. It's the equivalent of an open diff when you don't have torque being applied.
So mechanically, what we have going on to accomplish those three things, we have in here two different ramp angles on the wedges. So there's a series of clutch plates that are stacked outside of that. There's a wedge that when you apply torque, it drives into the two housings, pushing them out and compressing the clutches. The two-way would have an angle equal top and bottom. The 1.5 way has the standard one-way angle on the top, but on the bottom it has a shallower angle, so it creates less outward pressure. And a true one-way has a flat section on the off throttle side.
We decided to go with a 1.5 way for a couple of reasons. If you think about like the amount of time that it takes to go from fully open to fully locked, it takes the same amount of time whether you're going from 50% locked to fully locked or 0% locked to fully locked. It can be a little bit unsettling to a car. And with the Bmod being such a short wheelbase, we decided that going with a 1.5 way would be less likely to upset the car during that transition. Versus with the RX-8, which is a very long wheelbase, we wanted it to go as open as possible because the chassis is inherently more stable. On most newer chassis, Geiken actually only makes one cone spring. So like on our RX-8, we don't have the ability to tune it. Like what's available is what we can get. On this particular unit, that we had 3 different cone spring options.
They set the minimum pressure on all the clutch plates. So that's the lightest locking action that the differential will ever have.
So if you took a 1.5 way diff with a stiff cone spring, it's not going to go as open as a 1.5 way diff with the softest cone spring. In a mod car, which has a very, very fast transition time, it's important for us to have this diff lock right away. The moment it senses that the inside wheel is starting to slip at a different speed than the outside, as we're starting to apply throttle, it needs to go into that locked motion to avoid the one wheel peel and give us the true diff action on throttle.
How quickly it locks up is some springs that hold against that wedging action that I talked about first.
Good news. If that just sounded like a foreign language to you, Luot is really, really good at listening to, what your complaints are, what your desires are, just from a handling perspective, and then being able to take that and apply that to the diff tuning. And so he actually recommended this exact setup that we're going with.
We've talked about the diff a lot at this point.
The whole video is about the diff.
Yeah. So as I was going into CAD, I had a few key design constraints. Has to be chain drive, obviously. We wanted to move that chain drive sprocket outboard so that we could have a straight run from the motorcycle transmission back to the differential. Currently it goes through a jack shaft, gets an offset there, and then comes back onto the housing. Basically, there's a machined housing around the outside of the differential, but it's on the housing. We're going to need to actually space that off out here into space. Another thing we're looking to do with this is going to tube brakes. So we found this Willwood. It's a single piston, which is kind of weird for race car stuff, but what that results in is that one side can be quite thin. Yeah, you have to add brake pad thickness back to this, but it allows us to package things a bit tighter. And that'll let us get a brake outboard the sprocket on the driven side and kind of in the general mirrored area of where the sprocket is on the non-driven side.
All right, so digging into the CAD. What we have here is our baseline model. This is to show how everything fits together and make sure it's all feasible. Dive into a section view here. So down in the center we have the BMW OSGiken. Then we have a pair of stub axles out of a BMW X3. Coming outside of that, we have the two machined housings that will contain all of the oil around the diff. Both sides ride on a bearing. I've got two options that'll fit just about the same. Need to tweak slightly based on which one we use. One's a sealed bearing, the other is more of a trailer style taper bearing. CVs here, these are actually the mating CV to the BMW part. We'll be pulling those off of the axles, having the axles re-splined to mate with the VW outer CV joint. These two gray parts mirrored are stand-ins for the diff support. Coming out towards the sprocket side, you can see that we have a spline type fit on the left side housing, and that goes into this sprocket adapter. We also have some tapped through holes to get us pinched down onto the left side carrier. So power transmission comes in through the sprocket, carries through this adapter into this side, through to the right side housing, and into effectively where normally you would have a ring gear. Looking at the output side of the equation, we have our BMW stub axles. They come out to BMW CVs. We have another adapter spacer here that runs out to our inboard outboard brakes. So the idea is that it's independent braking for each of the rear wheels. Currently the diff is braked effectively on either this sprocket or on the ring gear flange equivalent, which means that whatever brake forces you're applying wind up going through the functional components of the differential. So we're going to tag onto the bolt pattern for the CVs. Make adapters, they'll be a little different from right to left. And this is a standard Willwood part. And then this is the single piston Willwood caliper that we showed in the video. So plenty of things to refine, adjust, and get ready for machining, but the general layout works. We have space for everything, and it looks like we should be able to make this happen.
Told you I could talk quick.